And we can do the simulation as well. To show you the results, I will do the simulation. Here, this is my input. First, I will fix the radix to constant decimal for both. This is my input. I will give the force constant to, for example, and you will see it will show the results of 4, because in the y test we just did multiply by 2. Okay, and you can do another for value, just test, just multiplying by 2. Okay, this was for a scheme where we implemented AP none. Then we will implement AP handshaking. For that, we shouldn't close the project. We will do just upgrade by here AP HLS. Now it will create the handshaking interface for our pointer. We will do this synthesis again. And then export IP. Okay. Here you can see it's integrated the log, resets and control signals. We'll do just export. Export is done, and when we came here in our Vivado, you see the IP at the backend is updated, so we need to upgrade. Okay, we'll just rerun system. As you see here, it's edit the control signals for the handshake. We will do just insert a clock resource, and here you can see edit the clock signal, and this is the processor system reset, and here it's automatically connected with the wrist peripheral reset and the clock are common. Now we will just make it external, both the clock and reset signals. We will do both valid and acknowledgement signals as an external. And just save, reset the products, and regenerate output product. We have updated our IP for the handshaking, and here you can see we updated our wrapper as well, and they have initiated the control signals for handshaking. And we will do the same simulation again. We can see here we assign our input 3, the output is 6. The logic is same as we implemented before, and here you can see the clock signals and the valid and acknowledgement signals. Let's jump to the third approach, FIFO based interface. So for the FIFO we need 2 pointers, one for input, one for output. I will do A1, A2, and here I need to do the FIFO interface type. And this for A1. And I will do same synthesis and export IP block. Synthesis done. Export IP block. Finished. Here the IP is updated, so we refresh. Now this is our input. We will connect with the switch, and this output we will connect with our LEDs. Okay, and we need to use these 2 input empty. I will give the constant values. Delete the previous signals. Okay, we need to give these 2 inputs, full and empty. So I will the constant reset output products. Generate output products. Updated our wrapper, and we will do the simulation again. That's our output. I will give the input value force constant 3. As you can see here, we have done all 3 tabs interfaces of pointer in HLS and exported IPs to Vivado and run the simulation. So I hope you have learned about the pointer in HLS and how we can use it. Please subscribe this channel, follow the channel, and share this video. Thank you very much.